Welcome to episode 6 of Building a Smart Farm. It's me and Gabriel Koch of Agro Patterns. So we've been off for a little while. The last time I was here was 3 weeks ago. I've been on vacation, which was lovely. What have you been up, Gabriel, in the last couple of weeks?
Interesting you ask. I've been busy, Tom. I attended with some good friends, folks from Blues Wireless and also from Bantu, who is our manufacturing team partner in Colombia. So we went to Tech Hub Live, an ag tech conference in Indianapolis.
Wow.
It was rather warm. It was rather warm, Tom.
Yeah, it was hot in Cyprus as well, boiling. It's boiling now.
It was boiling. Yeah. It was boiling everywhere, but I learned a lot about technology for agriculture. Fascinating conference. I felt like what we are doing fits in quite well with the direction of the ag industry. A couple of things that I learned. People in agriculture see technology as augmenting their workforce, not replacing them. And that's really important. So what they want to do is just really improve processes with the aid of technology. There's also a big push for IoT devices, sensors, but more complicated solutions as well. We saw drones, we saw moving cameras, we saw meters, obviously the temperature and humidity sensors. And I joked around a little bit after being there for a couple of days that the most used word at the conference was growing degree days.
Oh, really?
Everybody talks about growing degree days because it's about predicting yields and predicting harvest time. So that was quite interesting.
Was that conference just growing things, or was it about cows and cattle as well?
No, it was actually technology for agriculture.
Are cows not part of agriculture?
No, not much about animals. Mostly about plants.
Oh, interesting. Yeah.
But I saw devices where they mix up all the different chemicals so that they measure everything as they mix them, so that they don't waste anything. We saw organic companies that are using technology as well to measure the efficacy of their organic products instead of the chemicals that are used in some fields. So there's a lot happening. There's a lot of concern based on the geopolitical situation in the world. And whatnot. So it was fascinating. I felt like I don't care much for conferences, but this one was the exception. I felt like I had something to offer. Now, one last bit of information before we jump in. Fascinating for me to show the WhatsApp interface and how receptive people were about a very simple approach.
Oh, did you show us stuff?
We did. I did. And people were very, very receptive for the following reason, because most people that work in agriculture are in the field. They're not there's no office. Farms don't have big offices. So really, really interesting. And another issue that a lot of people brought up that I don't know if it's within our scope is that there are a lot of data silos, and there are a lot of people that spend too much time trying to aggregate information from multiple sources. It's a nightmare. They actually it's all overhead, but it's all people trying to merge data from different sources, different formats and whatnot. But at some point, that's an interesting problem to tackle.
Yeah, I feel like most of the jobs I've done have involved, just moving data from service A to service B. That seems to occupy 90% of the software workforce ad infinitum. You'd think we'd have a better way by now, but it seems to be very manual. And this is the good thing. This is where web code shines, I think, because the webhook integration we demoed in the WhatsApp stream we did. The beauty of that webhook integration was that you can code it as data comes in. You can trap that data and code off data as it actually happens. You don't have to do it from a manual. You can do it live off what's happening, and that developer experience, I think, is unique to web code. So we do have a lot to offer in these kinds of connecting thing from A to B, which is a big problem. It takes too long. So anything that speeds that up, I think, is a good direction to aim for. So what are we going to do this week? You got any ideas?
Well, yes. Okay, let me show off some stuff. I've been building prototypes.
Oh, what's this?
Well, this actually is called a workbench, and it's from my friends at FaceDock, but it's almost a Lego set where you can connect different electronic components. And one of our clients has asked for he has the idea of creating the greenhouse of tomorrow. So
Nice.
automating fans, automating curtains, turning lights on and off.
Oh, actually automating the actuators in the greenhouse.
So our WhatsApp interface is going to be the remote control of the greenhouse.
Oh man, that'd be cool.
Yeah. So I've been playing around with it, and the idea is to create a little model. If this works well, creating a 3D model at a 1 to whatever scale. And if that goes well, then let's just build a greenhouse of tomorrow.
So in our previous streams, we were just taking sensor data. Yeah, what are all the parts on that workbench?
Okay. Good question. So we have obviously the breadboard.
Yeah.
This is a note carrier and a note card as well.
That's the thing we've actually been interfacing with. This is Blues Wireless stuff.
That's correct.
Yeah.
This is, if I can't do this. This is a relay.
Solenoids. Yeah, I recognize that. Yeah. That's power electronics. Yeah.
And this is obviously the MCU.
MCU microcontroller unit.
Microcontroller unit.
That's the brains.
And I have a little motor here. What else do I have? I have a lot of gadgets here. I have, I'll show you some fans. And I have some fans somewhere. Oh, we got a packet here, so I'll show the little fans, just like computer fans. But
that's sweet.
It's fans. And just to round up this thing,
you're gonna build a mini farm, a real mini farm using computer fans. Oh, that'd be cool.
And then I have this tag, which is really interesting. We're trying to figure out the exact location of people that work inside the greenhouse, and GPS doesn't cut it.
Yeah, there's all reflections and blah, blah, blah. Yeah, it's not accurate.
Exactly.
Yeah.
So that's what I've been up to while you've been in Cyprus, Tom.
Yeah, well, yeah, I mean, that sounds very productive. Yeah, I was just on the beach, sunning myself. Yeah, so these node cards, they're capable then not just of taking sensor data, but also we can write back into them and tell them to do.
That's correct. They're bidirectional.
Oh yeah, that's very exciting. So yeah, there's a lot of things we can go from then. Yeah, we've got all the integration there. Yeah, we should actually try and twiddle some switches or something. That would be fun. Okay, but for this week, what's our topics? Productionization. So I think what we aim to do today, we would like to, like the tarot, which reminds me we should do tarot. Like the tarot, we want to put things on a custom domain. So we want to take our charts that we already have, and maybe like how you would have a real website, you would have a website with its own name. Maybe you want to escape the notebook a little bit and put it in your own domain. So we'll prototype how to set up a custom domain for that. And then the other thing, if you're running these things for real, like we have a process where Blues is sending us sensor data periodically and we're putting that into the database. Anything that's like a long running process, you should also monitor it. So if something goes wrong, and something often goes wrong randomly, you want to get an email or maybe a phone call to say for some reason things are broken. So monitoring is another important aspect when you try and put these things into production. So this week we'll talk about these productionization topics, and maybe we'll do some other stuff if we get to it. Oh, I've got a fancy new microphone as well. You may have noticed if I've got clear audio, hopefully. Oh, and the other thing I noticed last week, you can't really read my screen very well, so I'm going to bump up the font a bit. Okay, so here we are, episode 6. Productionization. Oops, it's in capitals. Started bad. Productionization. And the major things we want to put is a custom domain and error monitoring. Okay, so this is our sensor data that we were collecting. This was actually from the WhatsApp episode. And we've got a few sensors. What we want to do is take this chart and we're going to put it in a dedicated website. So I'll just start here. So put chart in embed. Right. So there's a few different ways you could do this. So if you look, if I search for Observablehq and embedding, so there's these notebooks that show you that you can take individual cells, and if you look over here, there's embed. If I click that, copy the URL. If I now paste that URL, it says it's not found because I've not published it. So let's get this in the public. Let me also set the URL as productionisation, if I spelled that right. No, I have not. Productionisation. It's going to hurt me looking at that. So we've published that. When you've got a published notebook, one way of embedding it is copy that link. And I think, yeah. So this is the easy way. And when you do it this way, you end up with these details around the outside. If you look at the source code, then you know what Observable adds is a style sheet, and they have a little bit of analytics in there. What's annoying is is it annoying? Yeah. Well, anyway, there's just stuff there. This is probably the easiest way to do it. Let's maybe start with this way, and this is something you can embed in an iframe. So if you have a normal website, this is pretty easy to embed. Well, actually, what I regret is also we wanted that chooser as well. Let's get the chooser as well. So and you can embed more than one cell. So yeah, this is cool. So now we have this little data control with there's a little bit of branding over the top. Let's go with this. So that's the kind of thing that can be put in a website. So let's create a web. Now there's lots of ways you can create a website, but as we've got web code already, let's just deploy it as an endpoint. Import endpoint from endpoint services. Okay, so when we create this, let's just quickly check this works. Rest.send hi. Now if we open that link, hi, yeah. So this endpoint's active. Now what we want to do is create a very simple website. So let's define the HTML in a HTML cell. This is the general structure. H1. This is the new aggro patterns. Aggro patterns v2. What should we call this page?
Server. I mean the sensor page.
Okay, sensor page. So what happens when you type it like this? It ends up rendering in this cell. But we can still give this cell a name. The sensor page, right? That'd probably be more accurate. So we've called this cell the sensor page, which is HTML, but this is the source code, but it's actually instantiated it. So if you use the debugger, you can actually look inside that. Jumping around. There we are. Yeah, you can look at it. This is actually being built into the DOM. So my point is that if we now refer to that cell, it says it's a HTML element. So what we actually want is the HTML when we're sending it over the wire. So we can call outer HTML to get the source code of it, and that is what we want to send over the wire. So now when we refresh that endpoint, we've got our very basic web page. Now what we would like is to embed our chart there. So let's generate that again. So we want the dashboard and the sensor name. We want it as an iframe, and then it gives us this code we can use. Copy. Great. Then I'll click out of it. So that's the code to embed it. By the way, it's formatted. There we go. Okay. So let's see how that looks. So when we click enter, it'll realize it in this page. So this is funny. Now we've got like a real Inception thing going on. But this is still working, right? And now if we refresh this, yeah, we've got it. It's thinking. Boom. Okay. So this is a very straightforward, fast way of embedding stuff. Maybe, is this good enough, or should we get rid of this as well?
It'd be nice to get rid of it. Basically white label the work that you do in Observable.
Okay, yeah,
right?
let's fully do that. Okay, so yeah, because we've got power over generating. The other disadvantage to this, when you look at the source code, these iframes are opaque. So custom styles you apply here don't necessarily cascade down here. When you create an iframe, there's like a separation between the top level and what's going on internally. Now, if you trust your code, and because we wrote that code, we trust code, there's no need for that iframe, and it causes a certain amount of friction. So one as well as removing the branding, another good reason that you might want to take control of the embedding process is also so you can get rid of that iframe. So I've got a notebook already that does this. So custom embed, example of a custom embed. So just because I can't remember how to do anything. So here they deploy a web server and they just send the page rendered, much like we did. Oh, and also in this example, some cache control headers have been set. Just to make it more efficient that you can cache pages. And then there's a function called page that does the rendering based on parameters. I don't know where these parameters oh, the parameters are up here. The title, the description, that kind of thing. And then if we actually look at what the page function does, yeah, this is just raw HTML, so it's not going via a HTML cell this time. Sets the SEO tags. This is maybe not important if we're using it to embed in a website. But then this is how you do a custom embedding. So import this runtime in an inspector. I think if we embed observe, the first one we did. So that code that it's talking about there is not, is there an advanced techniques? Advanced embedding a cell on a web page. Yeah, this explains how to do it where you load JavaScript. The observable runtime you can import as just normal JavaScript and then sort of fill in your notebook and then tell your notebook to write its results into the body, or you can do it at more specific in more specific granularity. So there's more information to explain what this is doing, but we're just gonna copy all this. So we need, I think, up to here. So we'll put the title, and there's gonna be a script tag, and then we're gonna import the runtime, import the notebook. Right. So the notebook, we need the notebook name. I think this is its name like this. Tom Larkworthy productionisation. And then create the runtime. If the name is display, we're going to write into the display. There's two things we need. We need the display and we need the chooser. Okay, so if the name equals, and it's got to match the sense and the cell name. So if the name is dashboard, let's call that dashboard to keep these things similar. If the name is dashboard, put it in there. Else, if the name is, and the other thing we need is the chooser. So view of becomes part of the name when you're selecting these things. So if the name is view of query sensor name, then you should write it into the chooser. And I think we don't need this anymore. I think that should work. So if I hit enter on that, it does it. It doesn't execute it. One of the quirks of the client-side embedding is that things inside script tags are not executed. Let's see what happens when we refresh this. Hey, yeah, okay, so now it comes up. Yeah, and it works, right? Does it? Yeah, it changes. Yeah, yep. So that's this is a lower level way of doing embedding, and what's nice is now we've eliminated that iframe. So this is just like your JavaScript, your page under your full control. But it's coming out of it's loading the notebook data from Observable. So if there's any changes made to this notebook, this page will automatically refresh. So what I also like about this design is that Observable is still the authority, the single source of truth on the functionality. So if you start messing about here, your website will update automatic.
Oh, isn't that what you really want to do, Tom? This is the beauty of Observable in web code.
Yeah, exactly. That's what I like. That's what I like about it. I mean, some people say, maybe it's a bit dangerous to not have a deploy step, that changes that happen here. If they, it's slightly dangerous not to have a deploy step. But if you are the type of person that want a deploy step, the way you should work then is fork this, have another endpoint, test that out. When you're satisfied, your forked one becomes your staging environment. And then when you merge it, then this will update the production one. So just the fact that this happens all instantly and live without a deploy step does not exclude these other ways of working, right? So if that's not your cup of tea, you can still do it. Whatever workflow you want is available. But I love this workflow where it's like so fast and immediate. because we can develop that much faster. Okay, so that's like the basics of embedding. Now, what we want is a nice domain name. So let's set up a custom domain. I've tried a few different ways of doing this. Using Netlify is the fastest, I think, that I know. And I have tried to test that none of this is going to actually, hopefully, right, let's do it. Right, first we need a custom. We're going to do everything from scratch here. I don't know if I've got my wallet on me. Yeah, I do have my wallet. Yeah, we're going to do everything. We're going to use, obviously, the worst possible domain name possible so we can get it at the lowest price possible. So let's generate a random name. This is the one I used to use. Yeah, okay. Maybe it was a random string I used to use. Okay, that'll do. So some random gibberish. So what domain would you like to use this one? Oh, maybe because I need a .com. Is that the issue? Is available. Is it cheaper if it's even longer?
I have one in case you need it, but that would take a little while to transfer all the stuff.
Did it do it? Did I click yes? Oh, I think I accidentally misclicked there. Oh yeah, I got it. Great. Right, I'm going to disable auto renewal because I do not want to pay for this again. Okay, so we've got that. So step one is we now own .com. Next thing we want to do is put it on a website. So let's create a new website. Okay, let's deploy manually. So this is what's cool about, this is why Netlify is so quick, is you can just set up a site and drop it in that, and then bam, it will be live. We all our assets though, we've already done this. We've built the site. So that's what we're going to do. We're going to use Netlify as a reverse proxy. So Netlify will deal with registering the DNS, having these servers listening, but whenever a request comes in, we're just going to forward it to this web code address, and that will be the key to a custom domain. And I wrote an article on this one somewhere. Custom domain in 4 lines of code, because I can't remember how to do it now. This is all you need to do. Basically, yeah, you just need the Netlify toml, which is like a metadata file. That's all we need. Let's see if we can do this without even touching the file system. So the other thing Netlify supports is configuring a website via a GitHub repository. Import an existing project. Oh yeah, connect from a Git provider. Choose the Git provider. Okay, right. Okay, let's create a new repository, and the repository name will be whatever the website was called. Website for blah, and it'll be public. Let's create that. So now we have a GitHub repository for that, and now we want to. Okay, so we want to boot this GitHub repository. We'll just quickly copy these ones. Will that work? Okay, so now this repository contains that README. What we really want to do. See, this is weird. Why can I just added a file without building that README first? Because other than that, I want to try and avoid using native tools. So we had to use a native tool there. All I want to do is create this file in the base of that repository. So the netlify.toml, and all it is an instruction to Netlify servers how to redirect onto our web code endpoint. So this is to this was actually when we set up the Taro Online, which reminds me. So this is the name of the endpoint. And then the splat means, so if an incoming request had a path on it, blah / blog1.html. So the request would have a lot of details on, and this redirect rule matches anything with the star operator. So any path that comes in to the Netlify website, if an incoming user, no matter what their request is to our custom domain, that will be captured in this star, and it will redirect it to web code endpoint, and this little bit at the end there appends whatever custom path was matched here. So no information is lost. So we can use this one endpoint, and there's ways of having a look at the full request, the path that came in. We can use that one endpoint to serve everything from the website, which is handy. So that's our file. So I think that's correct. So let's commit that. Okay. So now that's the basic layout, and now we want to connect that to Netlify. So we want Netlify to search repos. We want the repo, this one. But I don't think I've given Netlify enough access. Only select repositories. So I only want it to be able to access whatever that one was called. That one. Okay. Oh no, it got it. It's great. Okay. So Netlify should connect to that. I think that's all we need. Let's see what happens. So if we deploy that, so when you first create a website in Netlify, it gives you some gibberish name, which is where we want to test before connecting that up. Site deploy in progress. I don't know how long this takes. Oh yeah, there we go. Site deployed. Right, so if I open that page, hey, look. So
Fantastic.
now this silly name is redirected to here, which is cool. Now the final step is to give it a nice domain. So we'll now add a custom domain, blah.com. Maybe, there we are. Oh no, that's all I need to do. Okay, right, waiting for DNS propagation. We could not provision Let's Encrypt certificates. Yeah, so it's important, it's very easy getting a website up and running, and it's a slightly more difficult to get that S to make it a secure. This is what we need the SSL certificates and whatnot for. I'm surprised it hasn't done it automatically. Oh yeah, there we go. We just had to do it. We're ready to provision. Okay, provision it. So I think probably the only issue is that this is not propagated, rather than there's any actual fault here. Well, let's just see if our custom domain's working. So yes, look at that. Our custom domain is now loaded that, but it's got this awful not secure bit because we haven't got the certificates provisioned yet. So this is only HTTP, and that is not production ready. We need it to be HTTPS, which is here. Oh wait, your site has HTTPS. It worked. Right, it's working now. Let's see. So the important thing, does HTTPS work? Yeah, there we go.
Fantastic.
So there you go. How was that? Oh, that was fast. Custom domains.
Fantastic.
That's the quickest way I know how to do it. And let me if I just explain this bit, what you can do with these redirects. If you've got a big website, you only want like parts of it to be redirected to web code. You want the paths to be on your custom domain, but you don't want everything on your custom domain being handled by web code. You just want certain parts done, and that's where you start manipulating this from. So instead of doing a wild card and saying any incoming request forward to web code, you would go anything from sensors/star should go to this, and then you can slice your domain up into different regions and have them handled by maybe even different web code endpoints as well, whatever makes sense. So this doesn't have to be an all or nothing thing.
So let me let's go back to our business case, agro patterns.
Yeah.
So we do have the sensor data in Firebase, and we have plenty of other data in Mongo.
Yeah.
So this would be a case where we would have that subdomain where that star would be /sensor, whatever the case may be, and we would be pointing to the notebook, to the sensor notebook instead of. So we could basically embed the notebook in a page inside the agro patterns. Or agro patterns application.
Yeah. So the only the big thing is that you have to give Netlify control of your domain. There are different services for provisioning and managing these kinds of domains. So many of them also have equivalent functionality. I find Netlify particularly slick for doing these kinds of tricks. So that's the big loss of control you're doing is the request first has to come in, hit Netlify servers, and then you can go anywhere and via that Netlify TOML is the configuration. But if you're already got an established business and you're already got a website set up, then the first step one is migrating to Netlify for your website hosting. Not necessarily for hosting the domain, but certainly for sending the initial request. So that may or may not be palette. For new websites, it's super easy. Okay, so that was part one of what I wanted to achieve today. You might also notice it's a little bit, it comes up and then it's that and then it's that, right? We can dive into what is causing these slowness if we clear everything out. And then we should be able to close that console. Here we get what is actually loaded when this renders. The first request to at the top level to load the page is this one. Where does it say timing? 160 milliseconds, which is not bad. It could be better, but that's pretty good. So that's the delay on the first request is a combination of going through Netlify servers, which is pretty fast, and then hitting the web code endpoint, which at the moment we're actually doing live tunneling. So then it actually has to come to my developer's machine and be served. But this is web code overhead. Once it's warmed up, this should be below, hopefully below 100 milliseconds. So the first request is pretty quick. But when you look at then what happens is there's this huge amount of loading JavaScript, all the dependencies for the page. Now, if we look in the details of this, like DuckDB is being loaded right now, and that's because this notebook actually does DuckDB. For the application of actually serving this graph, we don't need DuckDB. It's loading a lot of unrelated functionality, which is slowing it down a lot before it actually renders this page. So this is because this notebook is quite complicated and does a load of unrelated. So if you want your web page to be a lot faster than this, where it's blank and then loads. So you see, the first bit was fast. I refreshed, it was pretty much there. But then it was slow when it actually tried to draw the graph. That's because there's tons of stuff coming in, most of it unrelated to the task at hand. So if you want this to be faster, you have to cut these notebooks down and just concentrate on the bare essentials, because this is the way web code works, is that this whole notebook is run in order to serve incoming requests. So there's just too much stuff happening, right? But that can be tuned. You can make it a lot faster than this.
Let me ask you something, Tom. So if you wanted to run DuckDB on your data, would you have a separate notebook where you do the analytics in a separate notebook than the graph?
Well, it depends what I was using DuckDB for. If I'm using DuckDB as a back-end process to do pre-aggregations like we did a few weeks ago, it doesn't really matter because it's a background process that just runs every hour or something. So then I wouldn't care about latency. If, however, I'm using DuckDB to actually, process these data points in order to produce an actual graph of something, I don't think there's any way around it. Yeah, you have to bring DuckDB in. What you could try and do is do the DuckDB in a webcode endpoint, render the graph rather than sending. So the way we're doing the embedding here is by actually executing the notebook client side. This is what this bit's doing. This obviously means that all the dependencies used to draw the graph have to be imported, and it's actually reading it from Firebase and all the rest of it here. You could try and save time. Instead of embedding the notebook, you could do what we did in the WhatsApp one, where we render it to an image and we just send the image over. In that case, right, in that case, it will go a lot faster. This will load in a lot quicker because it's only one image coming over. But then you lose the interactivity, right? And you lose the real-time aspect because this is properly wired up to Firebase. So in 15 minutes time, there'll be new data points coming on. This is a living interactive document. Whereas if you try and save performance by sending just a static image over, yes, it's a lot quicker, but now it's no longer interactive. So it depends on your application, really.
I mean, from a use case, from a user perspective, I think the WhatsApp use case is one where you send the image, and a website is where you interact with it.
Yeah, that's how exactly. That's how I divide them. Yeah, because you can't embed interactive controls in WhatsApp. So there it makes sense to render the image, and we've done that already. And then, but in this use case where it's going to be in the website and you want them to just like a dashboard that is updating, then you want to be connected to executing the actual notebook. But do at least slim your notebook down. So we've just been forking notebook for weeks now. And obviously there's a lot of extra stuff that is not relevant at hand. So we could trim that down. We could make this one a lot faster than it is. Okay, so I think that's enough on that topic of custom embedding. So the other topic I want to talk about is these notebooks. There's always a risk that something goes wrong. Maybe Firebase is down. Maybe a dependency changes. Things can crash. And code that you wrote 6 months ago may not run today for random reasons. So whenever you put code into production, especially when you're trying to build a product around it. So if we want this website always to be very reliable so our customers can confidently go to Quafawa and know that their graphs are there, we need to continuously monitor it and make sure that it's all working. So there's a few different techniques for doing this. So the first one, my favorite is, I wonder if I don't really want to be logged in. Yes, can I create a new, maybe it would be better if I create a guest account. So the first technology I use for detecting errors is Sentry, which is a JavaScript library. People usually use it for monitoring their websites as a front-end technology. It installs in the website and it tells you whether there's any errors have occurred in the page, so that when a user is using it, if for whatever reason there's circumstances that the user viewing the page encounters a crash, it will report it. And this means, maybe they're using a browser you've not been able to test on, you'll pick that up. So I love Sentry for monitoring a certain class of errors.
We've used Papertrail so far. Would this be a replacement for Papertrail?
What is Papertrail? Cloud-hosted log management. Yeah, this sounds different. This is useful for aggregating all your cloud logs together, so you've got a search interface over them. So that's, if something is reporting errors, then you can search all your logs to try and figure out where the error's coming from. But yeah, Sentry is something that is installed into web pages and automatically reports errors as that page encounters them. So these are different. Sentry is free for a fair amount of usage, and then you do have to pay for it. Or if you're ambitious, you can actually self-host it because it's fully open source. So you can also self-host it, although it's quite complicated to host. really, really, really complicated. So I have a notebook already for notebook monitoring with Sentry.io. So in order to do this, we have to import it. Let's see if this works. Right, I already monitor all my notebooks through this footer thing. So I'm just going to disconnect so that we can do it fast. Where was the web? Now we're going to monitor with Sentry. So we have to import it, step one, and then we have to instantiate it with we have to instantiate it, and we have to say what namespaces it applies to. So as it's still me, we want this to apply for just this DNS, the something key. So we have to look that up somewhere. Does that work? Invalid DNS name, the DSN name. Okay, that makes sense. So let's see if we can let's see how hard it is to register a new one. So I have a few custom accounts. So sign in. I don't know how easy this is going to be. Sign in with Google. Another account. New organization. Go for it. Your organization's name. And the thing it needed was a DSN name. So we've got to have a project maybe. Choose platform. This will be the web. Can you see web there? I don't want JavaScript. That's close enough. I'll create my own alerts later. Yes. So configure the JavaScript. Right. So now we've got this DSN name. Now, okay. So I think that's all we need. So what this does, hopefully, this is now configured to, if there's any unexpected errors on the page, it will report it to this Sentry dashboard here. So let's see. So I think I can, if we refresh this, double check we see Sentry fly past. Sentry? Yeah, there we go. Something installed. Yeah. So I think Sentry is now installed. Now I believe, I don't know if this will work, but we can try it. Error. I am an error. So I'm gonna artificially throw an error in the console, and that was an uncaught error. I think that's enough. So it says there wasn't. But normally when Sentry's working, if you throw an error that it actually catches, it'll immediately make a network request to report that there was an error. So that's not. I know why it is. I know why it is. It's because if you look at what we've actually booted up is only these 3 cells, but our sentry is in its own cell, so that's never executed. So that means it was never set up. So that's a gotcha. That's why we test. Got to test. Otherwise, these things. So in this case, we don't actually want to, put it into the document. We want this to be a behind the scenes thing. So in this case, and this is in the embedding information, you just go return new to say, yes, you want to observe that data, but there's going to be no visual component to it. Right, so there's 4 equal signs. If I refresh, nothing. Let's try another one. How would we debug whether this is working? But the self URL is this. Okay, I see what's happened. Okay, so then it's ignored it because it's do not initialize sentry for unexpected namespaces. This kind of makes sense, actually. Okay, damn, that's annoying. So this sentry is scoped to only work in Tom Larkworthy's notebooks, but because we put it on a custom domain, that's not true anymore. We want it to also execute there, so that's what that actually means. So there we go. The power of debugging. Okay, let's the reason why we have this namespace filter is because people in Observable are permitted to just fork your notebook and customize them. What you don't want accidentally happening is error reports from someone else's code modifications to your source code. So say you have a nice service set up and it has very few errors. Someone forks your notebook, they change the code, now it's spewing errors everywhere. You don't want those errors entering your system. They're nothing to do with you. And you don't want to be accused of spying, installing some kind of spyware in their systems. So what this namespace does is say, these are the places where I want Sentry to work and don't work anywhere else. That's what that does. And of course, because we just set up a custom domain, that's a different place. Sentry shouldn't work that without us authorizing it. So by adding that, I've now authorized that custom domain. So it tried to send to blah, 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 and it said it was blocked by client. Now, I wonder if that's my ad blocker. I'm going to turn my ad blocker off and refresh the page. Now, if I throw an error, yes, it's fine. So it's just so people with ad blockers will not send Sentry reports. Fine. If we look at the network tab now, after I threw that synthetic error, we see some stuff went out. That's a success. This is not updated. I don't think it's a real-time feed. So if we refresh that, fingers crossed, yeah, look at that. I am an error. Woo! Great. So that's the basics of error reporting, and this is critical for finding out whether, there's mistakes with the website that are incompatible with Safari, or, just something changed, nothing to do with you, a dependency changed, the internet changed, there's an error thrown somewhere, and this will automatically collect them and give you a single dashboard you can just review and make sure everything looks good. Yeah, so that's the first. So that's one kind of error monitoring. I would say this is like passive error monitoring because, you're letting things run and you're just checking that nothing unexpected happens. The other type of error monitoring is active monitoring. So the generic health check, what this does, it can load any other notebook and check if it has any errors. Okay, so where we were on this, we've got a known cell, and this gets picked up by the generic health check notebook, which exports this as a URL we can just query. So after filling out in the health check notebook that we wish to check our target notebook for errors. So we configured this to check productionization. The notebook would just run for errors. We run that, and indeed our cell that has a known error throws. Step 1 is getting it to run in this notebook. Once you've figured out the right set of parameters and it's working, you can copy that as a URL, which is a web code URL, which actually executes the health check. So when we refresh this one, and because we set the wait to 5 seconds, we have to wait 5 seconds for this to boot that other cell, run it. And this tells us that, yes, there's a known error. Actually, maybe even more interesting is if we do it with the network tab open. Did I refresh it? I did refresh it. the status comes back as a non-standard status code. When there's an error present, it throws a 503 to indicate that there's some kind of error. And this is now useful because of this non-standard error code, this kind of thing that could be picked up in other standard software packages. So Uptime Robot, so we can now actively monitor this. I use Uptime Robot, it's quite a good one. It's free for up to 50. So we're going to ask it to monitor a HTTP endpoint. We give it the URL, the monitoring interval. Okay, so that's created that. Now when we look at the logs of this, there's no incidents because it's not run yet. Now it's registered, it's down. Yes, so it's showing it red, and you can look at the logs, service unavailable, and it's saying it's an error because there's a 503 which stands for service unavailable, but it actually sends you what the response, see the full response. There we go, and it will download it so you can debug it. But the response was exactly what we saw from the error health notebook. So with these two types of error monitoring, I think you'll catch a lot of errors. The nice thing about this active monitoring is having this robot ask every 5 minutes and check whether our notebook's running, is it means it'll detect errors even when no one's using the product. So this is great for early detection, so you find problems before your customers do. A disadvantage of it is it runs it through a web code endpoint, which is only one type of environment. So web code underneath is a Chrome browser. So if you have any errors related to different browsers, it won't detect that. But it will detect things even when there's no usage. So for certain classes of errors, this is the fastest way of finding errors. And that's why it's useful to also use Sentry. Sentry will detect errors that users encounter once they're actually using the application. Maybe some errors require you to click around the interface a bit, or it might be only occur on certain browsers, in which case Sentry is another way of detecting errors, a different set of errors. What's cool about Sentry is it's errors as generated by the users. So it tends to be a bit more like, it picks up a lot more interesting use cases. Tends to be quite noisy because errors can be caused by network problems, and it'll find all the rare cases. So Sentry's great. If you can get your Sentry error log down to 0, it means you've really made a robust system. So these two things complement each other, and if you're going live, I think you should always have both on there, and that will, hopefully keep ahead of all the problems before encountered by customers.
I think this is really important. This is carpentry, and it's hard, but it's required for putting the systems in production.
Yeah.
It's not the flashy stuff that we have done in the past, but it's what's required for systems to run smoothly in production.
Yeah, I've had to concoct these systems because Observable is a data viz platform, and it wasn't in their product description that you should be putting these notebooks on the critical path for customer facing analytics and data processing. So there's not many features to help you with this process of going to production. So that's why we've had to figure these things out ourselves. But what's encouraging is it is possible. So some people have a few reservations about using Observable on the critical path or using any notebook environment. And yes, it is.
But what would be a better alternative than this for visualizing data? That's the question I had, and that's why it drew me to web code. Was that we basically had to develop something, test it, and then deploy it, and that could be very cumbersome in traditional environments.
Well, exactly. The way Observable wants you to use it is to develop your custom visualizations on their platform, figure out the code, and then copy it into a React app or whatever, and then use other tooling to actually deploy it into production. But they don't expect the actual notebook environment to be actually live in the browser generally. I don't think they expect people to do that. But if you do that, you can cut out a lot of steps and have a much faster development cycle. But this speed comes with caveats on reliability, how can you still deliver a reliable experience to your customers? And that's why you need these extra tools, which to a certain degree come for free in other platforms. So we just have to, figure out what we need and develop those tools and make sure those come along for the ride in production. Otherwise, something random will happen and you'll have an outage and you'll be angry at the platform. But you've just got to take responsibility and go, okay, I'm going to check that it's running every 15 minutes and ensure you do all those tests.
Now, is there any alternative to what you have presented today in terms of monitoring the health of your system?
There's many alternatives. So what one thing we've used is Sentry, which is a third-party service specialized in client-side monitoring. I would say they're the biggest, but I think Datadog will do it as well. New Relic. There's a few other big services that require you to install these agents to monitor in the environment, but they're all specialized for different parts of the stack. Sentry's specialized specifically, or it originally came out of JavaScript monitoring in the browser, so that's its strong area. And Observable is a client-side technology, so that's why I tend to pick Sentry for Observable. But there's a few different options for installing an agent into the browser and looking for errors. That's one part of the equation. The other part of the equation, I was using the health check monitoring to actually check within a specific notebook whether there were any errors. That's something that has been built with web code, and no one's really thinking about this problem. So I would say that is a unique service that if you want to go to production with Observable, you probably should use health check or a close derivative of it.
Now, we're also assuming that Observable has its own health checks, so that if our code runs on Observable and Observable is healthy, we decrease the problems in theory. I've been working on the Observable platform for nearly 2 years now, and I think the team is top notch and they are very fast to respond to errors, and every system I've worked on, it goes down at some point. So yes, I've also seen outages in Observable, but they're very, they're a crack respond very quickly, and usually these outages are some of them are 5 minutes, they're really on the ball and they get it running again. But their responsibility is to keep Observable, the website, running. And really that's a platform for running your code. Their responsibility does not cover whether your JavaScript in your notebooks runs, because they support people of many different levels of talent. So many notebooks are broken, and it's the author's fault. And Observable do not have a responsibility for monitoring user errors and notifying them, or they don't notify you at the moment. So if you do want to make sure that your code is running, then you do need an external process like health check. And now let's go back to the first episode where we're entering data into Firebase.
Yeah,
right?
the ingestion of data. Yeah.
Right. So where could that process break? Okay, so we have a user in the field. That person is working offline, and then you upload the data, or you try to upload the data into Firebase using web code.
Yeah.
With those commands that we reviewed a while back. If Observable is broken at the time, the data will never get to Firebase on the server, correct?
So web code actually caches the notebook. So if it's already in memory, which it probably will be because it's every 15 minutes, then if Observable goes down, probably web code will continue to run and data will still go into Firebase. The services that could go down are web code servers. If web code servers go down, so the way it was working was Blue Wireless was forwarding traffic from its cloud to our web code endpoint. If web code goes down, that'll be the end of the data processor pathway. We won't be able to accept payloads. I don't know what Blue's Wireless do though. Some systems have at least one delivery and they'll retry if they detect that the recipient is offline. I suspect either they'll retry, or maybe we're missing some configuration to make it retry. But to make these kind of pathways reliable, you need to spend some engineering time making sure that everybody in the critical pathway will retry if something goes down, because something always goes down at some point. The things that could go down are web code servers, Firebase could go down and that happens, or Observable goes down and that happens, right? And because we've got three, or even Blues Wireless goes down, right?
Mm-hmm.
If any of those four parties go down and it's additive, so it only requires one of them to go down to interrupt that data processing pathway, then we start losing payloads for that point in time. Now, hopefully everyone retries and it'll eventually, sort itself out.
Yep.
But the worst kind of errors that can happen are there's some kind of programming error, which means that even if the services are running, data will still not go into the system because we've just fundamentally made a mistake. Okay, so that's pretty much all the topics I wanted to cover for today. We did custom URL monitoring. Yeah, there we are. AgroPatterns v2.
All right. Well, soon we're going to showcase a whole system on web code and observable notebooks. So stay tuned, and it'll be a template for different types of applications.
Yeah. So I'm going to be away for a few weeks because I have a consultant gig that will take more time. So it could be as long as 5 weeks before we do the next stream. So I don't exactly know when the next one will be and what the topic will be, but when we do get back, it will be more IoT, sensor visualizations. I think, what are the topics that we're missing from AgroPatterns at the moment, do you think?
Well, we have the mapping part, which is interesting, interactive mapping.
Yeah, I think mapping's
we
lots of people want mapping, right? IoT sensors, given out position, put them on a map, or visualize the temperatures over a map and things like that. These are great visualizations for making data-driven decisions. So mapping, yeah, that's a big one we should do.
I think while you're away, I'm going to focus on building this model of an intelligent greenhouse, because that's a very interesting topic. The scenarios here are, let's say that the temperature rises, and by that only that in and of itself would trigger the opening curtains or turning on fans. The other one is just setting up an alert for somebody to then opening the curtains or turning the fans on. That's a scenario, and I would like to see this in a model version initially, but hopefully in the real world in the next few months instead of years.
Yeah, that would be super cool. That's like, as soon as you've got a sensor automation and effect in the real world, that's basically a robot at that point. So yeah, if we can send commands to the note card to actually turn motors on or something, that would be awesome. That's another big topic we could do. Then we've got a robot.
Hopefully just make sure that we're helping all these flower growers reduce the impact on the environment.
Yeah, increase the efficiency, reduce waste. If there's any topics that other people want us to discuss, if they've got an IoT idea and it's kind of in the vicinity of what we're doing, we can definitely think about taking a detour elsewhere as well.
There's going to be a lot of integration between hardware and software, I think, in the future.